return some review tests to you. Just go through the stack. If you should find yours there. If not, pass it on. Let me know at the end of the hour and see what happened. And then just pass the stack on after you've had a chance to look at it. Today, we're going to do some review. We're going to cover the 7th lesson, and we're going to finish up the morning with a quiz on the first 6 lessons. So I thought it was appropriate this morning, and to try to give me a little edge in the time, I'm going to leave what I presented in the last hour and use that from the board to sort of go through the review, and then I have space to answer questions. But what we're going to do, Debbie, is go to that space behind me, and we're going to look at that in terms of just where we've been. So we started, this is the computational review, and I'm not talking in any way right now about counting. That's not something you need to worry about. So as we look at this, we started with numbers. And we talked about notations. So we had 3 different kinds of notations. The verbal notation, where I say 2,000. And then we have positional notation, where I write a 2000. And then we have expanded. And that's where you take each of the digits and multiply the digit times its place value. So 3 different things we did there. That was the first lesson. Then when we went to the second review, we talked about addition. And there's probably only 2 things that are new there for you. One was the grouping by tens, and then this low stress method, and that was where you take on the low stress method and you do subtotals. Now, Debbie, at this point, are you in 1 or 2, or are you going to try doing 1, 2 over there? Yeah, Debbie will bring that in the other camera, perhaps. Let's see what happens. Yes. Here's the low stress method. Let's just go through this so I can erase that if I need. Here were my numbers. The numbers were 7, 9, that's okay. I don't need really to be on it. 7, 9, 5, and 8. Let's call this the moving hand. 7, 9, 5, and 8. So what you were supposed to do is start with the 7, come down to the 9, and you write the subtotal, 16. Add the 5, subtotal 21. Add the 8. So the low stress is you keep the 21 on the board or paper. You don't have to keep it in your head. Then we got 29. You are expected to reverse the additions, starting with the 8, adding 5, and you write the 13. You see this 9 and 13. That gives you 22. The 22 and 7 gives you 29. That's the low stress method, and that was a little bit new to you. As we come back up to the front of the room, subtraction. Under subtraction, probably the most new thing of the entire lesson. Whoa, okay. That's the Austrian method. Okay. That reminds me, Debbie, of the time when Jeff went ahead and hit the button for just a sort of a travel, and it just kept going around like this. So, early times. Austrian method. What was different about the Austrian method? We added rather than borrowing or taking away. So we did our subtraction as an addition. So if you're on 2 now or 1? I'm on
2, but I have 1 right there.
Okay, let's go with 1 here. And then what I want to do is look at this subtraction here with the Austrian method. This is just a review. And if I'm blocking your angle, just look at one of the monitors. We had 7, 5, 8, 6, and we're subtracting 2, 3, 1, 4. Now, I wrote this problem so that we don't have to worry about carries. And if you were doing this old-fashioned way, you wouldn't be borrowing. But the difference is the way this arrow is going. It's going up. So that means I want you to start down here where I blocked off the numbers, and you ask, what added to 4 gives 6? And your answer? The 2. Now, if you're looking at the monitor, you don't have the number below the 1. So you're asking, what can I add to 1 to make 8? And the answer is That's 7. Then I ask, what added to 3? Gives me 5, and you get the 2. And then finally, the 5 and 2 is 7. Everything is going up, not down. And you aren't taking away, you're doing an addition problem. So as we just pan that a little bit to the right, this problem was harder because every number in these 3 is a bigger number than the number above. So when I ask the same question, what can I add to 7 to get a 6? There's nothing I can add. But if I add 9 to 7, I get a 16. So the 16, I write down the 1 up here that I carried, making that a 10. So here's my 9 and 7 is 16. I carry the 1 over here, making a 10. Now what added to 10 gives me an 18? And 8's your answer. I carried, and the 7 becomes an 8, and so I ask, what can I add to 8 to give me 15? And that's where this 7 comes from. Again, 7 and 8 is 15. That made the 4 a 5, and 2 and 5 is 7. That's just the Austrian method for doing a subtraction. Okay? Now, Debbie, what I want to do is come back to where I had multiplication with shortcuts. So, thank you. Now, with multiplication, the only thing here that I think was new for you was most likely the shortcuts. So, what shortcuts did we learn there? Well, multiplying 9 times something was a shortcut. So 9 times 7, what did we do for the shortcut? Take 1 less than the number. Okay, 1 less than the number. So our 7 goes to 6, and then what?
How many it takes to get to 9?
How many to get to 9? It takes 3. 63. So 9 times 7, we drop the 7 to a 6, add 3 to get 9. And it makes it a nice shortcut to remember all the 9s. What was the other shortcut I gave you? Let's see, that's one a little bit hard to remember.
5.
Something about 5.
Squared.
Okay, not just 5 squared.
Wasn't it 25?
It could be a 25 squared, a 45 squared, anything ending in a 5 if I square it. So let's do 25 squared. What do I do to the 2?
Multiply.
Go up 1 to a 3 and say 2 times 3. That gives me my 6. And always at the end?
25.
25. 75 squared. I go from the 7 to 8 and multiply. 7 times 8, 56. Put the 25 at the end. So those are the 2 shortcuts for multiplication. Otherwise, we do the good old-fashioned algorithm with one possible simplification. And if I multiply by a power of 10, what can I do? So let's say I have 25 times 10 to the 3rd. What do I do with the zeros? Just put them at the end of the number. So I have 25 times 10 to the 3rd. 10 to the 3rd is 1,000. I put the 3 zeros after my 25. Okay, up here, right above where I'm standing, and that's fine, just where it is, we had division. And about the only thing there that was new, short division. So if I ask you to do something with short division, then you would do it without dropping things down. You would bring numbers up. That's the difference. And then finally, there is prime factoring. And that's what you did for me today. And it just takes a whole lot of time to do prime factoring. And it may be the most time-consuming thing on the quiz today. Now, Debbie, on the board I have the strategies for taking a test. Let's go to that cut. Now, test strategies. The question, what do we do with test strategies? And part of my concern there is, as you look at a quiz, because it's the beginning of a test, I'd like to explain what's different from this quiz to what you've been doing. Because it may not be obvious to you, and it's something you need to think about. Every review test, pretty much open-ended on time. Spend as much or as little time as you feel. But in a quiz or a test environment, the time no longer is open. So on today's quiz, 10 problems in 20 minutes. Now, if you've been taking 5 minutes to do a problem and relaxed and taking your time, suddenly having to do it in 2 minutes, more stress. So when you prepare for quizzes or tests, then one of the things you want to do is practice with a time constraint where you have to do something a little bit faster. Now I'm going to move over this way so that you can see something I've written here called the Pareto principle. Now this comes out of statistics, and that's the class that's at 7 in the morning that we're broadcasting on channel 96 at 7 in the morning, and we do it again at 5 in the afternoon, from 5 to 6 on channel 96 and Charter, channel 2. But the Pareto principle involves something that you've heard in a variety of ways, and it's like 20% of the fishermen catch 80% of the fish. So there's sort of 20-80 idea. Well, if you have 5 things that you have to study for a quiz, it really amounts to saying one of them will take about 80% of your time. And for most people, the Austrian method tends to be that one that still isn't setting there as comfortable as you'd like. So my point is this: if you're studying for a test and 1 out of the 5 things you're supposed to study is hard, what are you inclined to do? Spend more time on it, right? That's that 80% of your time on one thing you didn't do well on in the homework. What should you do instead? Skip that and spend 80% of your time on everything you think you know. As one of my professors said, and this wasn't until I was nearly done with a bachelor's degree in mathematics, he put it this way: make sure you can do what you think you can do. Now, one of the things that if you don't practice the things that you feel comfortable in doing, on a test suddenly you make this statement: I could do that last night. I know I could, and I can't do it now because you didn't practice what you felt so comfortable in doing. In a test, you tend to choke up a little bit, get a little bit uncomfortable, and sometimes that old response about flee, you run for your life rather than sitting there doing the problems. Mentally you do that and you pull blanks. So the argument, practice what you think you're comfortable in doing. 80% of your time there. Then that last part that's bugging you, look at it, see if you can get a little bit of an idea what to do. When you come to the test, do everything else first, then come back to what is bugging you. If you start doing the one thing that's just messing your head up, everything else can just blank temporarily. And the only time it comes back to you is when you walk through the door. You walk out the room, you walk out the door, you close it behind you, and then what suddenly comes rushing into your head? All those things that you couldn't remember during the test. It's really frustrating. Basically, you practice under a little bit of pressure and you over-practice the little things that you're good about. Then, when you're in pressure, they're pretty straightforward. So I think test strategy is important, and understand that you may not do as well on a quiz right now as you do in the review test because you're under a pressure of time. Now you have 3 quizzes we do. There were 18 review tests we'll do. So that's 3 100-point quizzes out of 2,100 points. So it's not going to destroy your grade, but it does give you an idea of what you're having trouble. The midterm. At 18th review, we will have a 1-hour test, 30 problems. So that's why I'm limiting you to 20 minutes for 10 problems. So you get into that kind of routine of working under some pressure. Is there any question on any of the things that we've got on the board, looking at it again, that you're uncertain about, would like to talk about? We've tried to look at all 6 of these. Okay, we're comfortable there? Then I'd like you to open your book to the 7th review. This is the 7th of what we're going to do. And I'm going to look at some things in that review. Trying to think how I want to do this, Debbie. Yeah, I understand where you are. Can you pan with me just over a little bit? We'll just come over here. That's nicely done. And what I'm going to do is use the document cam, and we're going to look at the 7th lesson. Now, just a comment for you. One of the things I've observed over the years, and it stays consistent all year after year. It's not like something changes. If I ask people, what is it that you really feel uncomfortable about when you think of arithmetic? I could ask the same question in an algebra class. I could ask it in a pre-algebra class, and the answer pretty much always comes up the same. Common fractions and mixed numbers. Working with fractions, for some reason, causes anxiety. And that's true every class. Fractions seem to be the concern. Now, interestingly to me, we go through these 15 weeks, 16 weeks nearly with the final schedule. And what you will not have trouble with usually is fractions at the end. Now, the one thing you're pretty confident about right now will continue to be more frustration than I'd like, and that's working with decimals. And that has to do with the rules about going to the right or the left and when you go back and forth. So to that extent, fractions aren't going to be as bad as you think, and we're going to use primes to do our work with fractions. Now, there are a couple things about fractions that I want to remind you of. A fraction has a special name. We call it a rational number. That means it's a ratio. A rational number. And it involves a ratio. Now, the typical kinds of common fractions that we're familiar with are here. Now, some of these you might write in different ways. For example, 3 over 1 you'd typically write as how? Be careful. 3 over 1 would still just be a 3. If we think of 1/3, that's its reciprocal when we do division. But as a 3 over 1, most of the time you just write it as a 3. But it's worth remembering that 3 over 1 is a fraction. These two differ in a very interesting way. The first one, 1/2, the numerator is smaller than the denominator. We call that what kind of fraction? Proper. The 7 over 4, the top number is larger, and it is referred to then as not proper or improper. Okay? So that's the difference between those two. Just a comment here while we're looking at this. 0 cannot be written at the bottom of a fraction. That gets you into deep trouble. Okay, so 0 cannot be the denominator. Now, with fractions, we go back and forth. For example, if I take this particular fraction, 8 over 5, it's improper. Most of you feel better if I write that as a mixed number in which I say 1 and what? 1 and 3/5. So you think of dividing the 5 into the 8 and get a 1 with 3 left over, 1 and 3/5. This, by the way, just for information, is another way of writing 0. So 0 over any denominator will be 0. Now I'm going to come over to some things I wrote on the board, and we're just going to look at these now from the standpoint of what I just said. A fraction is a ratio. 3 to 4, we sometimes write the ratio this way. And interestingly, we just finished a section in the algebra class on ratios that are equal, and we call them proportions. So this is a fraction, and it is proper. Here was your improper. Now, most of us, I think, grow up going through school and thinking that you're obligated to go from what? The improper to a mixed number. we do it as a short division. 4 into 9 gives you 2, 1 left over, so you write it as 2 1/4. One of the assumptions we make as we think of mathematics is that we are going to write a fraction so that it is reduced. We would like a fraction to be reduced, and by that we mean there's nothing I can divide into the top and bottom of the fraction. Remember, this is our fraction. Top, bottom, we name the numerator the top and denominator the bottom. There's nothing that will go into these two numbers other than 1, so we call it reduced. However, if I look at this result where I have 12 over 8, I can divide 12 by a 4, and I can divide the 8 by a 4. It's the largest number that will go into both the numerator and the denominator. 4 into 12 is our 3. 4 into 8 is our 2. We say we have reduced the fraction. We say that we have canceled. And that's one way of rewriting a fraction so that it is reduced. Now, a comment. This is reduced. This was improper. When I take the improper fraction and write it this way, I'm not reducing. One more time. When I take the improper fraction, 9 over 4, and I write it as 2 1/4, I'm not reducing the fraction. I'm just changing the appearance of it, the form of it, but I'm not reducing. Now, these two look different, but I didn't reduce anything. 9 over 4 was reduced. The 12 over 8 had to be rewritten, but as a reduced form. And whenever you give me an answer and you have a fraction, I want it reduced. Are you obligated to take an improper fraction and rewrite it as a mixed number? And the answer is no. You are not obligated to that. It's your choice. But when I say that, there's a little caveat I should include. If you're going for a job and you're taking one of those tests where they say, we want to find out how you do with numbers, and they give these two answers, which one do you want to write down for that kind of test? The 2 1/4. It will be preferred, typically, as the better answer. What's interesting, if we think of where we're going with this, we're going to add fractions, subtract fractions, multiply them, and divide them. We're going to do all that. I don't want to leave a fraction like this. I'll want to reverse the process and what? Go up to here. Now, I hope you're familiar with the process where you take the 4 here and say what? 4 times 2 plus 1, that gives you a 9. 4 times 2 is 8, plus 1, 9 over 4. So what we're going to do now is slide over a little bit, Debbie, to balance about here on the left, justify. Thank you. And I'll just move over here. Here's where I've shown that process, where you have 4 times 2 plus 1. That's a 9 over 4. Again, most of you are more comfortable leaving the fraction this way as a mixed number, but when I have to use it in a multiplication or division, I have to go backwards to the improper fraction. Now, one last thing about lesson 7. I want you to look at what I did here. 12 over 8. Now, we said before we reduced it to 3 over 2. I have taken the 12 and written it as a product of primes. 2 times 2 is 4, times 3 is 12. I've taken my 8 and written it as a product of primes. 2 times 2 times 2. Then what I do is search for the same prime in the numerator and denominator, cross it out, and put 1s. I had another 2. Cross them out and put 1s. So that left what? Just the 3 and the 2 These 1's multiplied together doesn't change the 2, so I have 3/2. Now that is going to be called reducing using primes. And you're going to have a part of lesson 7 where that's exactly what you're going to do, where you're going to reduce using prime numbers. Okay? Now that is basically the idea. I'm going to ask you to name what fractions are called. And we're going to go back to the document cam for a moment, Debbie, and then I'm going to come back up front. And then we'll look at the things I'm asking you to do in the review exercise, because I'll want this to be done as we think of it for homework. I want you to read through here. There's a lot of writing I've done there to help explain the ideas. But on page 69, this came out of taking classical guitar. That's what led me to try this, where you designate each finger with a certain letter as you try to learn what you do with the guitar in classic work. But I'm using P for proper, I for improper, M for mixed, and I just want you to name these appropriately, which one's proper, which one's improper, and which is mixed. Then, in the second part, and I expect this pretty much to be something that you can do short division in your head. If you want to do it long, showing the work, that's okay. But 3 into 7 goes 2 with 1 left over, so you'd write 2 and 1/3. So here's where you're going from improper to mixed. Coming off there into the third question. In the third question, I have you changing the mixed number to what? An improper fraction. So here's a case where you're going to go 2 times 1 is 2, plus 1 is 3 over the 2. And I give you a variety of problems there. And then this is where you're going to do what I just talked about, use prime factoring to reduce. So this is our 12 over 15 on the board. So we come back to that problem. We had 12 over 8. If you can just show me the prime factoring without showing the division, that's acceptable. If you have to, in something like 4h, where we have 36 over 84, if you have to show me the divisions on that one to get it as a product of primes, then do so. Then we go all the way back to the back of the book, because we're interested in review test 7, and something here that in a sense is a review. So for example, in review test 7, that's page 195, I should probably just, there we go. You're to take 450 and do what? Write it as a product of primes. And so the question is, you look at that. Coming back to that for a moment, just staring at it. What are you going to do when I ask you to write it as a product of primes? What's your first step? Ouch. That's not a good first step. Silence. If I gave you the 450 and I want you to write it as a product of primes, here's your 450. First step. Well, what are you going to divide by?
2.
Well, your primes. So your first step should be this. List the primes that you may want to try. Then you do what? Start at the top of your list with the 2. Will 2 go into 450? Yes. So you write your 450 down here, you put the 2 in front, and you start dividing. And you divide by 2 until you can't do it anymore, and then you do what? Go to the 3 until you can't do it anymore, and then you go to the 5. Do it in order. Now let's look at the directions again on the review test. Write 450 as a product of primes, and when you get done, what do I want to see besides the division and the product? What do I want you to use in that product? The exponents. So if you have 2 to the 3rd or 2 to the 2nd, I want to see that. So I know in this case that I'll at least have 2 to the first. Okay, so with that in mind, going down the list, question 2, prime factoring. Again, that's what we just had on the board. Let's go to there again, Debbie. That's a 12 over 18. That's what I want to see in what you do. Thank you, 12 over 8. Thank you. If my conscience was not there, I would make more errors than I like. Rewrite the following as we look at the question. The mixed number as an improper fraction. You can do that in your head. And as I slide down here, the improper is a mixed number. If you can do that in your head, fine. And then as I come down to the 5th, here's a division that's going to have a remainder. I want your remainder as a fraction. So just like when I divide 4 into 9 and get 2 with a remainder of 1, we write it as 2 and 1/4. Same idea.